In 1943, in a series of lectures, Erwin Schrödinger presented to the world his latest reflections on the thermodynamics of living beings. That is, what are living beings from the perspective of energy flow, heat, and work? These lectures turned into a book called What is Life? Schrödinger's work contains two main ideas, two research projects, and yes, Schrödinger is known as the guy who puts cats in boxes, but he did more in life than just quantum physics, like he was also an expert in color vision. I'm not kidding. Now back to the topic. Schrödinger's first idea is the idea of order from order, which basically states that life must have some specific mechanism to reproduce its organization. According to Schrödinger, living beings had some kind of crystal inside them, and this crystal encodes the information of what makes a living being and allows the living being to propagate the information using this crystal. And if you see any similarity between Schrödinger's idea and what we now know as DNA, you're paying attention to the video. Damn this short video generation, Schrödinger basically predicted the existence of DNA in his work. He may not have gotten the details right, but the general concept he did. And I don't need to mention that DNA hadn't been discovered at that time. Schrödinger's second idea receives less attention, but it is indeed also extremely interesting. So much so that it's the topic of the video, and it's Schrödinger's paradox. The second law of thermodynamics shows that the natural tendency of the world is to go from order to disorder, from organization to chaos, from low to high entropy. But Schrödinger noted living beings are highly chemically organized structures, and they perpetuate themselves by maintaining this organization and creating more organization as other living beings. So, living beings seemingly seem at first glance to violate the second law of thermodynamics. That seems wrong. Nothing in physics violates the second law of thermodynamics. If you put all the ingredients of a human being in a bathtub, you won't see the molecules organizing themselves into a human being. And the reason this doesn't happen is that it is a violation of the second law of thermodynamics. But somehow, this is exactly what happened on our planet. So it seems something is wrong with our understanding of the second law. Schrödinger's idea precisely reconciles the second law of thermodynamics with living beings maintaining organization. And this project became known as order through disorder. Solving the problem can help understand how life originated, how it sustains itself, and what its energetic function is on the planet's surface. Or how do organized living beings arise and perpetuate themselves in a world where everything tends toward chaos? Schrödinger had a preliminary answer to this question, but to understand his answer, we need to understand the basics of thermodynamics.
Hey, Pedro here. This video you are watching was originally in Portuguese, my native language. This is the attempt of our team to translate it to English, and I sincerely hope you enjoy it. Your feedback is extremely important to us. Now, back to the video.
Thermodynamics studies energy in its most fundamental form. No matter what the energy looks like or who is using it, it should be possible to use thermodynamics to describe what is happening. And according to thermodynamics, energy exists in two different forms, either as heat or as work. Work is all energy that can be used in a practical way to change the world around us in a useful manner. And heat is everything else. It is the energy that cannot be precisely used to generate work, basically a useless form of energy. For example, your car's engine uses chemical energy within the gasoline to generate work, such as making the wheels turn. But it wastes a part of it, and this generates heat and warms up the engine as a result. And this example already contains the first two laws of thermodynamics in disguise. The first law of thermodynamics is the one that states that all energy is either work or heat. There is no third type of energy. What's more, energy is conserved. You never lose or gain energy. All that can happen is that one type of energy becomes another. And the second law of thermodynamics is the fundamental rule of energy transformation. Every process that performs work generates heat irreversibly. In other words, every time you use energy in a useful way, part of that energy becomes useless energy. And this process essentially cannot be undone. All used energy becomes increasingly useless permanently. For example, before the car's gasoline burns, the chemical energy is rich in useful energy and can be practically used to change the world. After being used in the engine, part of the energy continues to be work and moves the car, but the other part turns into heat, a low-utility energy. And there is a physical quantity measuring how useful a portion of energy is, which is entropy. If energy can still be used as work, entropy is low. If little energy can still be used as work and the energy is primarily heat, entropy is high. And if energy is basically just heat, this is the state of maximum entropy, in which all the energy has already been used. Another form of the second law of thermodynamics is the following. Entropy always increases. Everything in nature tends towards the state of highest entropy. And there is yet another way to talk about entropy, which connects it with disorder in living beings. The average order entropy, which is the organization of physical systems. For example, in how many ways can your wardrobe be well organized, with all the clothes neatly folded in the correct places? Few. There are few ways to organize your wardrobe. You need to fold all the clothes and arrange them. You might just move one or two things around, but that's it. A well-organized closet is a low-entropy closet because there are few ways for it to be organized. And how many various ways can your wardrobe be disorganized? There are several ways to mess up a closet. Basically, any configuration of clothes not folded is a mess, and this is a case of high entropy. There are many ways to be messy, and few ways to be organized. So much so that if you make any changes to your organized closet, you will probably mess it up a bit. It's easier to mess things up than to organize them. So entropy increases, disorder increases, and your room gets a bit messier, and you can use that as an excuse when they ask you to clean your room. And this is where Schrödinger's paradox comes in. Life can avoid the increase in entropy and maintain chemical organization. And it has been doing this on Earth for billions of years. To help you understand how strange this is, it's like walking into your room and seeing that all your clothes have folded themselves. Schrödinger's answer to the paradox was as follows. According to the second law, the increase in entropy only applies globally. In other words, the entropy of a whole isolated system must increase. Parts of the system can have a local reduction in entropy. In other words, order can arise at specific points in a multi-part system, as long as the total entropy of the entire system still increases. Living beings are not isolated systems. They have access to energy primarily from the sun. Life uses energy from the sun directly or indirectly to maintain its order and avoid, according to the law of thermodynamics. There is no contradiction. Moreover, to maintain internal organization, living beings consume and use large amounts of energy, which in the process increases the entropy around them. In other words, looking at the planet as a whole, living beings cause an increase in global entropy. Life literally pays a price to maintain order. Living beings do not violate the second law of thermodynamics. They actually contribute to it. And I could stop here. This seems like a good answer, but Schrödinger's answer did not stop with him. It provoked several other scientists to look at living beings with new eyes, thermodynamic eyes. The search for how order forms from disorder, and here, in their quest, they encountered another problem. Thermodynamics was not ready to deal with biology. Traditional thermodynamics had been constructed to describe equilibrium states. A state of equilibrium is when a physical system matches the temperature, chemical potential, and pressure of its surroundings. And for life, the only state of equilibrium is death. If you thought this video wouldn't have an existential crisis, I have news for you. Life's trick to staying alive is to use cell membranes to create a difference in chemical potential, temperature differences, and all the differences that are necessary to stay alive. And then use these differences to generate work that is used to maintain the organization of the living being and keep it separate from the world. It is precisely by separating from the environment and breaking all equilibria that life is able to continue living. To study the thermodynamics of life, to understand the flow of energy in living beings and ecosystems, we need to rewrite the laws of thermodynamics for out-of-equilibrium conditions. And before going into details, this is a current research project that is still ongoing, so things may currently change. We are going to see cutting-edge science in this video. The idea that has gained the most traction for forming the laws of non-equilibrium thermodynamics is gradient destruction. Gradients are simply differences, variations in some quantity. A color gradient starts with one color and gradually changes to another color. A pressure gradient starts with one pressure, gradually changes, and ends with another pressure. And the same goes for temperature gradients, chemical potential, energy, and everything else. You like gradients even without knowing it, because without chemical potential gradients, you wouldn't exist. Nature, on the other hand, hates gradients. This is the principle of non-equilibrium thermodynamics. Nature inherently tends to destroy any gradient that forms, and the more intense that gradient is, the more complex the ways nature will naturally find to destroy it. For example, if you have a slight pressure gradient between the sea and a beach, a gentle, pleasant breeze forms and dissipates the pressure difference. Now, if you have a large difference in pressure and temperature, for example, like in the collision of geotropical and Arctic masses, this forms a storm and even a hurricane. The hurricane uses incredibly absurd amounts of energy and mixes air masses by spinning rapidly. And in doing so, it dramatically destroys the pressure gradient. Breezes and hurricanes are caused by the same differences in pressure and temperature, but on different scales. Small differences, small gradients, generate very small effects in nature, and large differences can indeed generate extreme effects. In other words, nature will always return to balance and eliminate differences in physical quantities. And it is worth noting here that the state of equilibrium is always the state of highest entropy. There's simply no way around it. And now comes the cool part. The hurricane is an organized, isolated system that perpetuates itself. A hurricane has very low entropy and is an extremely efficient engine, but all this organization arises out of nowhere in the chaotic atmosphere. In the process of trying to reach the true state of highest entropy, the atmosphere created something extremely organized with low entropy. A hurricane is an example of order emerging from disorder, what Schrödinger wanted to explain about life. So a hurricane makes perfect thermodynamic sense when looking at the principle of gradient destruction. Two air masses with different temperatures and pressures separated represent an organized configuration with low entropy and high potential to perform work. This energy gradient needs to be eliminated, and nature will ultimately find a way to effectively mix the air masses and achieve balance. And precisely because the scenario is one of low entropy, there is a lot of work to be done mixing the masses. Then the atmosphere creates a storm that mixes the air masses quite efficiently. The order in a hurricane does not arise despite the disorder of the atmosphere. It arises to generate disorder quickly. The hurricane does not organize despite the second law of thermodynamics, but precisely because of it. And the same might be true for life. Life is an excellent energy dissipator, a natural destroyer of gradients. We use the energy gradient generated by sunlight falling on our atmosphere to create these bubbles of organization of complex life. And in the process, we transform the low entropy light from the sun into high entropy thermal radiation. But unlike the hurricane, the sun is indeed much larger than the Earth, and the gradient of sunlight cannot be overcome. The energy gradient generated by the sun cannot be completely destroyed, so there are indeed no thermodynamic reasons for life to stop perpetuating itself. In fact, all this energy on the planet makes it more likely that life will continue and perpetuate, finding different and increasingly efficient ways to transform solar energy into high entropy heat. More and more, life seeks out processes to try to achieve a balance that can't really be reached. And in this sense, life is not a thing, but rather a process. The process that the surface of our planet has found to try to achieve balance and resist the constant injection of energy from the sun. Just as a hurricane is a vortex of organized chaos reducing pressure differences, living beings are vortices of chemical stability trying to deal with the energy gradient imposed by the sun. And maybe that's what happened on our planet. Life didn't arise in contradiction to the second law of thermodynamics, but precisely to make it happen. In a way, we exist to help the universe consume all its useful energy faster. How will you use your energy today? Thank you very much and see you next time.